Hey there, Mr. Wilford here. I just wanted to go through Chapter 6, Section 3 with you. And we're talking about conditions for parallelograms in this section. If you remember in the last section, we were talking about parallelograms and some of the different properties of parallelograms. So now we're going to talk a little bit more about some of the conditions that are necessary to be a parallelogram. And let's first of all take a look here at some theorems. First of all, the first one here, 631, it's saying if one pair of opposite sides of a quadrilateral are parallel and congruent, then the quadrilateral is a parallelogram. So what we're saying here is that really what we need to do is look at one pair of opposite sides, and if they're parallel and also they are congruent, meaning the same length, then we must have a parallelogram. Then the other two sides must be opposite and parallel as well, and congruent. In the next one here, 632, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So now we're saying that if we have opposite sides that are congruent, now we're not saying all four sides, but just opposite sides, two pairs, then we must have a parallelogram there as well. And then 633, if both pairs of opposite angles of a quadrilateral are congruent, then we must have a parallelogram as well. So now we're looking at opposite angles. So if B and D are congruent angles and A and C are congruent angles, then again we must have a parallelogram. And so this theorem 631 again is shown here, and we have a proof here as well. But these are some of the three basic things that we talk about when we're taking a look at conditions that we need to have a parallelogram. And we talked a little bit about this one in the last section when we talked about what parallelograms are. We talked a little bit about this as well. A couple of other theorems here. 634 says if an angle of a quadrilateral is supplementary to both of its consecutive angles, then we must have a parallelogram as well. And again, we talked about this in the last section. Basically, if these two consecutive angles, angle A and angle B, if they're supplementary, meaning that together they add up to be 180, then we are also going to have a quadrilateral, which is indeed a parallelogram. 635, if the diagonals of a quadrilateral bisect each other, then we will have a parallelogram as well. So if we know that these two segments here, BZ and ZD, are congruent, and AZ and ZC are congruent, then we are also going to have a parallelogram as well. So if you look at a couple of these examples, there's some pretty good ones here. Using some of these theorems, we're able to algebraically find some of these variables that are given here as well. And so, for example here, show that this ABCD is a parallelogram for x equals 7 and y equals 4. What we can do is actually just plug in 7 for the x's and 4 for the y's, and we can kind of compare some of the things that we see here. And so here it's saying since BC and DA are equal, so the opposite sides, and AB and CD are equal as well, then we have to have a parallelogram. Same kind of thing is happening here as well. We're trying to find or show that this is a parallelogram as well. And here we're dealing with the angles, and we're able to look at consecutive angles here, and excuse me, we're able to look at those as 180 degrees. Okay, continuing then, just a couple of other conditions here, and applying them, and just kind of looking at a couple of examples here and determining yes or no these are parallelograms or not. And then some other proofs here as well that you can read through, and conditions for parallelograms kind of summed up.